So any questions? At least a few people have started thinking about assignment 2. You shouldn't wait too long to start that assignment. There are some conceptual issues you need to master, and then a few little details to get right. So last time I talked about mental pattern, and one of its uses was undo. So today I want to talk about another pattern, which, again, just one of its uses is undo. It's not the only place it's used, and that's the command pattern. Um, and the goal is to, what they say, encapsulate a request as an object. So that allows the request to be executed immediately or later. And so again, initially it seems sort of weird because what do we mean by request? Well, request just means, in language like Java, is we're going to call a method on an object, right? So instead of me saying, you do the X, I'll tell him, you tell him to do X, right? That's what the command pattern does. The difference is then he can wait and tell him to do X tomorrow or the next day, right? That means, right, the command needs to know who the receiver of the request is going to be. Command also needs to know the arguments that that request needs, right? And now when we, do these cute little diagrams, it just says, receiver.action and execute, but it doesn't show any arguments, but there could be arguments, right? And so here is just a simple example where I create a command on a counter object, and so on my execute method in my command, right, I have as a field, right, the counter object, and then I just call increase on it. And of course, in this case, there's a nice inverse, right? So it becomes easy to implement undo because I just decrease by 1, right? Addition has an inverse subtraction, and so I can. So now, again, I sort of cheated because, what if I only increase by 5 instead of just 1 each time, right? And then I would need, somehow I need to change the structure so it incorporates the argument 5.
If we call redo, then we're going to call execute on that one. Let's say execute, undo, and then something redo. So internally, it should be execute only.
Yeah, so the question is about redo, right? Well, redo just means execute again, right? So it'd be just called execute, right? So literally, the command just They call encapsulates the receiver, but it says a field that's the receiver. We also need to make sure we've got any arguments we need, and then we've got some method, in this case we call it execute, which then actually calls the actual request on the object, in this case increase. Simple, right? Now it's like a more complicated example, right? Where it's like, okay, um, if the command is to, in a word processor, I want to store commands, I need to know, okay, where in the text I'm going to change things. If I'm deleting things, I need to know what I delete, right? So I need to store that information. And so the details become slightly more complicated. It's not just the receiver and increase. It's, well, here's a text. Here's object contains all the text. This is where I'm going to insert text. This is where I'm going to delete this text. Well, this is a text I'm going to replace with this other text. And if I want to support undo, then I need to make sure I store all that, because otherwise I have to know where I've inserted and what goes and what comes back. Because there's no clean inverse, right, function. I have to just hardwire. Oh, if the command is to replace a word, then undo is, again, replace, but I have to store the word that used to be there, so I can then restore it to original. Of course, I could also, if I wanted to, I could just store memento, right? And then my undo of my command could take the memento and replace the inner state of the text. But it's probably easier just to capture what word we replaced and where it went, right? Than to create a memento of the entire text. What's that? Are these properties of the subject? Well, in this case, a text is a subject, right?
We want to store the location and replace
Right. We need to store the location replacement text. Yes.
keep all of these
in, in our command object, right? Yeah.
So this will be
Yeah, in our command, right? Yeah. Well, you've all probably come across places where you need a callback, right? I have a button, and I click the button, I need to do something, and so you pass a callback function to the button, so we can replace that callback with a command object. Um, some of this can replace with lambdas now, so it's not, the need isn't quite as great. We can store these for execution at a later date, different times. We can use it to support undo, because now when we do a command, we execute the command and save the command and have the command object implement this inverse, right, the undo. We can use it to help do logging, because now the command can actually perform the actual operation and at the same time, call some logging function to just record what it did. We can use it to build a little language. So I know this one tool, they use it for kids, help kids program. The name escapes me. But they have, various things you can do. You can build a little object, so the kids can draw objects, and then they can add operations to the object. And there's like move and rotate and turn and pen down, pen up, these types of operations. But then you want the, the student to be able, the kid to be able to write a little program. So, okay, they'll write programs. Okay, let's draw a star. And once you have a star function now, using, down and rotate, right? Now you want to draw a bunch of stars. So you want to create a star function. How do we do that? Well, using the command pattern, we can say, okay, how do you build a star? Well, if we have our basic commands, move so far, rotate so far, right? Pen down, pen up, then we can write a little program saying, move X units, rotate so many units, move again, rotate so many units, right? And you do the right number and you get a star, right? And so then we can create, a move command, a rotate command, right? And do that number of times and then store those objects in sort of like a compound command object and call that star, right? And so we can build all these basic primitives, pen down, pen up, move, rotate, maybe change color and things like that. We can give various primitives, make them into commands, and then how do we create functions? Well, we just add different combination commands in a compound command. And then we provide them with a graphical interface where they just drag and drop a move, and then they type in how far to move, right? And they drag and drop a rotate command, and so there's a palette of the various basic commands they've got. And they can drag and drop and build a sort of routine, and then they can label that. And then how to implement? Well, we just use a command pattern for each of the basic commands, and then a compound command for when they drag and drop and create little programs. So I can build a high-level operation on basic primitives, right? We can do that to build example I gave was this graphical program kids use to write little programs, but we can also think of it as transaction, right? What's a transaction? Well, we do these various operations, and if we then encapsulate each operation as a command, then our transaction just becomes a compound command. Here's a list, and then we go through, and if we then want to roll back, we just, again, we have the list of commands. We can just undo all those. Right? So we can use this in a number of different places. Um, Now, another place where I know uses a command pattern, there's this in-memory database. What's an in-memory database? Well, most databases like Oracle or MySQL or Postgres, right? The actual data is stored on disk, so you don't lose it. And so then the problem becomes to read that data is very slow compared to the processor. So usually what they do is they try and cache a certain amount of data in memory, but again, you're always going to have cache misses, right? And so at some point you have to go to disk and read the data, and that's slow. And particularly in the finance world, I mean, when you're trading stocks and doing all these financial transactions, um, you want to be as fast as possible, right? Another example where a trading company in Chicago actually laid a fiber optic cable from Chicago to New York. Why? Because they found a route that was slightly shorter than the route that the internet normally took, right? And so that gave them an advantage because their trades issued from New York, from Chicago to New York, reached New York faster than everyone else's by a few milliseconds. And that was enough for them to fund laying fiber optic cable from Chicago to New York, which is really expensive because you have to hire guys to go out there and dig trenches and buy the right of ways and right. So for them, time really is money, right? Um, and so often they'll use a database that stores all the data in memory. But now the problem is if you store the data in memory, all your tables are in memory, and when you update the data, you do it in memory. What happens if machine goes down, right? So one way to do that is you define various basic operations you want to do on your data and create commands of them, right? And then when you execute that, when you want to do those operations, the software creates a command object, executes the command, and then you can save that command somehow, right? You just serialize it or find some sort of format where you can write it out to a file, right? And so you just have this log file where you're appending all the operations you do, and then at some point what you do is if your machine crashes, you just go back and you rerun all the commands, right? So what you typically do is periodically you take the state in memory and you save it to disk, and then you wipe out your command file, and then as you do more transactions on it, you create this log file of all the commands. And so if you need to restart, you just read in the last state you stored, and then re-execute all those commands, right? So another example where we can actually use this command object in a different type of setting. And so when I first came across these type of databases, there's this guy from Brazil who was pushing it when he wrote it himself, and he claimed it was like 10,000 times faster than Oracle. Well, yeah, I mean, you're never going to disk to read anything, right? So of course it's going to be a lot faster. Um, or a little language, right? We can create a macro language. Yeah, so it decouples the object that evokes operation from the one who knows how to perform it. If we go back to the button example, the button doesn't have to know, oh, I need to perform this operation on this text, right? It just knows here's a command, I can execute on it, and I'm done, right? So it decouples that button from underlying text that it may want to change. We can add new commands because we just add new command objects, right? And then just create them when we need them. And you can, like I said, a couple examples where you can combine commands into composite objects to do little macro functions or functions, transactions. Now, when you start, if you ever use a command pattern, each command is usually pretty simple, right? Well, I need a receiver, the thing that's actually do the operation on. I then hard code the operation I can perform on it, and then I have to worry about any arguments, and if I want to sort undo, then I have to figure out how to do that. But again, it's pretty straightforward, right? It's not. And then you do this, and so the command class is usually pretty small, and then you do it again, and it's the same pattern, right? Oh, I need the receiver, and what operation I want to do on it, and the arguments, right? And pretty soon you realize there's a small little template that you're just copying and pasting everywhere, right? Changing the type of the receiver, the operation you do on the receiver, the argument list, right? And I do it again. Okay, different receivers, different type, arguments a little bit different type, and then I call execute on it, right? And I do it again. It doesn't take you too long. You're like, man, I'm just typing away, doing the same thing over again with these minor little changes. And so they talk about this idea of a pluggable command where I can just say, look, here's the receiver, and here is a function to call, and here's the argument list. And then the pluggable command, I don't have to redo it over and over and over again. Just say, here's the receiver, function, call, argument list. You can't do everything in the pluggable command, but with all the simple cases you can do, just create one pluggable command and then configure it for each specific type of command you want to do. Here is a extremely awkward way to do with reflection in Java. If you ever find yourself doing this, you'll come to dislike reflection in Java, and you should think, oh, this is not the right way to do this, and be correct. Because now I can, again, it's a template in the sense of, I can give it a receiver, and I can give it the method I want to call, and list of arguments, and make a structure I can pass them all in, and then I can actually execute that, using invoke and on the receiver and the arguments. But then we get all these weird exceptions. And what happened, then someone has to catch them, and it's like, now that's going to percolate through my system. And you really want people catching these weird exceptions all the time. And to use it, you get to do all these crazy things where, how do I specify the types? How do I specify the method? But it gives you an idea of what we mean by a pluggable command. We're going to we create one class that handles many of the cases, right? There's a receiver, the method I want to call, and what arguments I need. And I can then write code to handle all that. Well, it had me to write another, class A, class B, class C. Every time I want a command, I don't have to tweak that little pattern. Fortunately, now there's a better way of doing this. We can use lambdas. Right. And so I can pass in lambdas and what to do. Java lambdas have restrictions on them. But again, it's giving you an idea of what you probably don't realize how boring and tedious it gets to do different commands for every particular little thing you want to do. And there are a lot of places where lambdas can replace the command itself. Again, if you want to create a little language out of basic primitives, each primitive we can encapsulate in a lambda, and then we can just store a collection of lambdas and just execute them one at a time, right? You don't necessarily need to create a new object to store the receiver necessarily. We probably do it with lambdas. Often logging, we just need to call a function, right? Say, here's, I'm at this spot. This is what I did. Our world is changing as normal. So functional programming is becoming more common. And from the functional programming side, they say, well, we don't need necessarily the command pattern. First of all, in simple cases, we can just use a function. We can pass on a function and execute the function. But the function needs state and receiver. We can also do that just using functions. Right, so here is a simple example. I'm creating a counter, and it's just a function, right? But in that function, we do two things. We create some states, and now we return a function that operates on that state. So it's like a small little object, right? Because it does have state and it does have operation. Whoops. Right, so I can create a bunch of counter objects and I can then execute them, right? And that state is recalled, right? Because closures remember their local environment and keep track of it. So when I call counter A, I get 1 returned. When I do counter A again, I get 2, and I get 3. But B remembers that it's just at 1. So if we have closures, we can create sort of a mini little object, right? We don't have to create there's no class name, right? Field, and then a function, a method. We just create a function. It's definitely not as full-featured as an object, right, or a class, right? We only get basically one operation returned from our function, and that's about it. That people are familiar with this idea, or is this something new? So obvious you want to say anything? It's so bizarre you don't know what to say. Right, so functions can maintain state, right? Not a lot of state, but you maintain state. And we can actually return, well, in this case, we're returning basically a tuple. So we return multiple functions. And so now I can have an increase and a reset, right? So this comma returns basically a tuple of functions, and then I call it, and then deconstructing, getting the first function, the second function, so now I can, right? No. But language like Swift, um, Kotlin, things that we can't do things like this. That's what happens in this field is we build something with computer architecture or a language, and it works for a while, and after some time we sort of get some new ideas, and that the ideas we did over here sounded good at the time, right? Based on the limitations of the hardware and our knowledge of software. And then N years later, it's like, well, we think we've got a better idea. And so the young guys come in and say, you old folks, you just go away. And we create new things, right? But it becomes hard to modify those older things because, right? Swift can come along and say, well, we're starting from scratch, so we don't have to worry about all that old stuff. Where Java's like, well, there's probably billions of lines of Java code out there, and we just can't really change things right away because if we break half those lines of code, people are going to scream at us like crazy, right? So their hands, what they can do, right, becomes somewhat restricted. Can we use static? The question is, won't this be the same thing we use static? And the answer is no. And the reason is because when you got static, there's only one copy in the program. And here I've created two separate copies, two independent copies. If I created these static variables in a class, I only have one copy per program. Oh, we're going back to here. So it's, some people have complained that the design patterns as we know them really are just almost specific to certain languages and certain language constructs that are common. And so they complain that, well, they're not really truly design patterns. It's not truly a design, not the way Alexander wanted it in terms of being sort of a general language, because there's too much variation between computer languages and how they operate. But that doesn't mean they're useful. But what we see happening is like this: is different language constructs come along, and they say, well, they will help reduce the need for certain patterns, and we can then start doing things like this, where I define some sort of command type, and then I can create functions, concrete functions, and then I can, create a command type, and it needs a execute and undo operation, and so I give those two functions to do that. And now I can call execute on that command type, and now I can call undo on that type. Right, sort of applying this command pattern idea to the functional world. use the right pause. I should probably tell a joke, waiting for people's mind to read the slide and catch up. Again, we can't do this in Java, right? It's not going to work. But conceptually, right, we're going to find a type, and a type can have, elements to it, right? And once we do that, then those things can be functions. And then when I create one of those objects or those data types, I create those two functions and give it to them. And now I can create a function which takes in those command type and accesses that field, and that field is a function, so I can execute it. Right? And these fields can have a state. In the case, as a receiver, right? I could also then store, if I need to, parameters in this counter function. It sort of becomes a way of defining, implementing a command pattern without classes, right? It's just a structure, some general purpose functions, and now I create another function to create